So again, coming back to geology, I think I'll use some examples of the processes. Remember I said that materials and processes are the two key aspects of the broad field of geology that relate to the medical geology or geology and health. So of course we see that earthquake and what happens, all the havoc and volcanic eruption. That is a picture of Mount St. Helens and the cloud of the smoke and ashes and the gases that were released. You can see that. But the question that I posed earlier, that is there any relationship between the earthquake, and occurrence of diseases? Well, this is a very hard name, I cannot pronounce it, but you can do it. You have my salute to you. That's how most of the Americans are. So we'll use the word valley fever.
Is that Latin?
It must be, Latin or Greek, I don't know. But anyway, the point here is that this is a disease that is endemic in this part of the country, southwestern United States and western part of the country. And the thing is that this is carried by a certain spores. The bacteria that reside in the spores, and the spores are available in the soil all the time. So when the condition of temperature, which is of course a warm temperature is there, and a strong wind blows, then of course they migrate from one place to the other and people get sick. It has got all kind of manifestations from simple rashes and all that, temperature. In the worst case, skin eruption could be on the face and all that. It is very ugly. I had some slides, but I didn't put it in here. So that is a disease that is causing a lot of concern and problems. But the key question is that is there a relationship between earthquake and this? Well, so here is an interesting graph. What we see here is that the date in 1994, we'll see the significance of this date later. And this is, of course, how many cases of valley fever were reported during this time period, which is, again, about 6-7 weeks, beginning from January to the March. So 8 weeks time period here we are looking at. And this is a diagram, this is a pie diagram, not pie, bar diagram, that tells you how many incidences occurred on a given week or so on. So that's the normal distribution, as you can see. But so what we see here is there is certain time period that's very obvious that somehow between January, later part, last week of January, and the first week of February, the incidence peaked in about 40, 44 maximum, and then it tapered off. Well, if I superimpose another thing here. Some of you may remember North 3 earthquake that occurred in California. It was a pretty powerful earthquake, 7.9 or something. And of course, it affected that surrounding area also. So then in this case, what happened, and the theory is that when the earthquake occurs, we know that the ground shakes. And when the ground shakes, it stirs up the loose and dry soil. And in those loose, dry soil, you have those spores where we have the bacteria. So when the earthquake occurred, it stirred up the soil, wind came and blew it, and of course people inhaled the dirt, it got into their system and started the higher incidence of valley fever. So there is a good example of how earthquake in particular could cause a higher incidence of a certain disease. Volcanic eruption is very well known, but I'm going back in time, later part of the 18th century in Iceland. In Ireland and Iceland, Ireland area actually, this is from Ireland. Lochie eruption is called in geological literature. But what we don't realize most of the time on the side of the light, too much light is coming, you may not be able to see it. If you want to darken the room, I will talk better. This was an eruption that came through a series of cracks in the ground, like the way it is happening below the oceans here. In the Atlantic Ocean, we have got a series of cracks in the crust of the earth through which the molten lava makes its way. And that same kind of thing you can see on the land also in many places. One example of that is the Columbia Plateau basalt or volcanic rock in the state of Washington and Oregon. It all erupted through a series of fissures of cracks in the ground over a period of 10 billion years, intermittently off and on. So that is the example of that fissure eruption. So you've got huge gashes in the earth through which the lava came. And sometimes it comes out, sometimes it forms little hills also that you can see that are called cinder cones. But the key thing to point out here is that along with the lava and everything that comes out, they had about, it's estimated that 120 metric, I think it's million tons of sulfur dioxide was released, and then 6.8 million tons of hydrochloric acid and hydrofluoric acid. Now these are all very toxic gases, you know that. And then this whole eruption occupied an area of 15 cubic kilometer and so on and so forth, I mean the volume and so on. So, but what was the implication of that? All it tells us is that yes, it was a huge volcanic eruption. A lot of this stuff came out of it. But then there was a study done, people have gone back, and what this graph tells you is that the same time period, you see that was 1783, this was the winter of 1783 and 1784. So that is the time period when most of the volcanic material came out along with the poisonous gases that we talked about. So we are right here. So what you see here is that average death and birth rate and all that. But you see here, this is the period when there was a huge increase in the number of deaths. And that has been attributed again to the eruption of the gases there. This happened in the recent time, not too long, 1991. Many of you might have remembered it. This is Mount Pinatubo in the Philippines. And this was one of the few major volcanic eruptions that was predicted almost very accurately by the geoscientists. And again, the challenge with the earthquake and volcano is that we have not developed the ability yet to make accurate short-term prediction. Yes, an earthquake is going to occur along the New Madrid Fault in southern Missouri on June 6, 2012 at 6 a.m. We just cannot do that. And same about San Andreas and everywhere else. All we have done is long-term. Yes, there is a good chance, there's 60% probability that an earthquake of 6.8 is going to occur along the New Madrid Fault in the next 50 years. So we are doing long-term prediction. It helps some, but not too much. And same with the issue with the volcanic eruption. We are getting better, and this is one example of success, that the team that were monitoring Mount Pinatubo, they said that, well, conditions are right, and we have to make an official announcement and ask people to evacuate. There were some skeptics again, that's always the case in the team. They said, well, what about that? We don't have that indicator. So it becomes a value judgment at that time. But the team overall prevails, well, forget about it. We don't have all the 100% certainty, but we still have to make the forecast and issue the warning. So they agreed to that, and of course the Clark Air Force Base happens to be in this area. Clark's Air Force Base, I don't know if some of you have been there or not, but that was US base there. So they contacted the commander of that base. They said, well, this volcano is eruption imminent, and we would like all the 30,000 or whatever men and women to be out of that, evacuated. Now that was a major decision. But they took the risk, because if that doesn't happen, then what? That's the big question. So they said, well, we are going to issue the warning anyway. So they did issue the warning. The whole base was evacuated in time, and of course, hardly anybody was hurt. But again, this is the kind of material that came out of that eruption.
Is there any radioactivity in any of that?
Fortunately not. That's one good thing. Yeah, we don't get, there's not much radiation that comes out of that. No, although there are radioactive elements are there, but no, they're not significant or any reported radioactivity that we have to worry about, and the consequence of exposure to the radiation. So we talked about the processes, and let's look at the materials: minerals, rocks, soils, and so on. Again, remember the fact that everything in the ultimate analysis is made up of the elements that we are all familiar in the periodic table, same elements. Now, of course, we know that mineral extraction, mining and everything, refining and all is going on for a long time. And here are just a few examples. These are known. Black lung disease in coal miners. This is very common, known for a long time. Silicosis, when you are working in metal mines, you are using the drill rigs and all, hand rigs, drills and everything else. And if you don't wear protection, which they have not done for a long time, well, you breathe the fine particles of silicon and other mineral dust, and that gets lodged into the lung, and silicosis is the name of mesothelioma. You must be seeing that on the TV these days. Almost every evening news, some legal company is putting out an ad. Do you know anybody who has got mesothelioma? You work with asbestos and all that? Well, this has become a big legal issue these days. It has been going on for the last 10 years. Libby is a small town in Montana. I happen to be there, where the largest asbestos mine is there, and there are high incidence of lung cancer and death due to mesothelioma in that area. And of course, many of the products that are used all over the country and world perhaps, well, they have the asbestos, and so they are trying to find out how many people are affected.